I'm Dr. Sri Banerjee, epidemiologist, biostatistician, associate professor. And in this segment, I'm going to be going over how to run simple linear regression um, from SAS. And SAS is typically known as code-driven. A lot of different functionality could be done through code. Now SAS has turned into more menu driven. There's a so the research question that we're going to be looking for here is how does age so how is age how is BMI connected to depression? And the measure that we run for depression is the Kessler scale. And so you can look up Kessler, Kessler, and see how that's calculated. So I've gone ahead and calculated the Kessler scale, preliminarily, and so we can run this regression sufficiently. So for starters, if you go to the left-hand side, look under tasks, there's multiple areas that you can look. So server files and folders is the top one. And then if you go to the second one down, you see a multiple menu. And so data, graph, map, statistics. What we're interested in, you can even do survival analysis. And that's basically what I use frequently. But you can also use linear regression. And what I'm going to do is select linear regression. And then I'm going to show you how I actually entered this already, but if you go here, then you can enter a variable that's there that you can add. So here's the continuous variable. Categorical variable has already been, or excuse me, the dependent variable has already been added. So how does BMI, how does Kessler 6 predict BMI? So that's the question that we're trying to answer. So the Kessler 6 is added to the continuous variable. And so I went here and added the Kessler 6 here. Basically, since I've already added, I don't need to do this, but you look for a continuous variable here. And that's basically what I had. I looked for the continuous variable and found continuous versus continuous, and basically as simple linear regression. So because this is a large data set, about 1 million people have participated in here. And this is going from 2008 to 2018, 2019, in fact. So there's a lot of different data points, which prevents us from looking at some of the diagnostics, but good to run. So the next thing that we're going to look at is how to put it in a model. So when I go into edit, if we take a look at this, there's multiple years that you can add. Not years. There's multiple variables that you can add, but the one we're interested in is Kessler 6. So here it is, and you can add this, and then this will pop up into the model effects. So hit OK. And then once you have this, you have the code that's already in there. And a lot of times people just type in this code, but I think when you're a beginner, then you want to use the menu-driven skill. So what are the options? There is the option of diagnostic plots and panel of plots, but the maximum number of plot points is 5,000. So if you have anything above 5,000, then this won't work. So, and that's the case here. So since we have this generated, go ahead and select run. Give it a moment. And then you'll see that the number of observations used is 320,185. And the number of observations read is 1 million. So as you can see, these are very difficult to try to run. And so because there's so many data points. The main area that most researchers will be considered important is p value. So this is the p value less than 0.001. So the question that we posed is that does is BMI predicted by depression level, or it does depression is depression connected or associated with BMI level? And the answer is yes. But you can take a look at the model errors. For instance, you can look at the F value and sum of squares and the adjusted R square and adjusted R square. That's so just looking at the output, I know that some of this might be truncated, so I apologize for that. But the first analysis of variance, what you see is that this is not very significant, but well, the statistical significance is pretty high, but this basically means that this is more significant than the model that only has the intercept. So that anything that has the model that we're trying to fit is way better than the intercept alone. The R squared is a very significant sort of number. Now, this is not very this is not a very high variability. Basically, when you have this, so just going back to the R square here, so typically you express this in a percentage. So this means that the R squared of 0.13% means that model explains 0.01 0.13% explains the variability in the outcome. So the variability of 0.13% of depression predicts the outcome of BMI. So that's not very strong or high, but this is something that's important. So the remaining 99% is due to error or something of that nature. So that might be random chance or whatnot. So again, R squared of 0.13% means the model explains 0.13% of the variability in the outcome. This is a very important sort of thing to look at other than the intercept and the variable. So of course, taking a look at this, the intercept is significant, but more importantly, KSL6 adequately predicts BMI, and that's significant at p less than 0.05. So this is kind of the basic way that you can run statistical analysis through menu-driven methods of SAS. I hope this has made some sense. Thank you for listening.